In this module, you will learn about the Maxwell-Boltzmann distribution of molecular speeds. The speeds of the individual molecules of a gas do not remain constant. The speed of the molecules of a gas changes due to the intermolecular collisions and the collisions of the molecules with the walls of the container. However, at a given temperature, the distribution of molecular speeds remains a constant. This distribution of molecular speeds is given by the Maxwell-Boltzmann distribution law. According to the law, for a given gas at a given temperature, a graph is plotted between molecular speeds on the x-axis and the fraction of molecules on the y-axis. The graph obtained is called the Maxwell-Boltzmann distribution curve. The important features of this distribution curve are: the fraction of molecules traveling at very low or very high speeds is very small. There is a certain speed for which the fraction of the molecules is the maximum. This speed is known as most probable speed. The most probable speed of a gas is the speed possessed by the maximum number of molecules of the gas at a given temperature, and it corresponds to the peak of the curve. Most probable speed is related to absolute temperature T by the equation C star is equal to under root 2 RT by M, where M is the molar mass. From this equation, it is evident that at the same temperature, lighter gases move faster than heavier ones. For example, nitrogen gas moves faster than chlorine gas. Now, let's study the effect of temperature on molecular speeds. Consider that a gas is under observation at 3 different temperatures T1, T2 and T3, where T3 is greater than T2 is greater than T1. The Maxwell-Boltzmann distribution curves at temperatures T1, T2 and T3 are shown here. From these distribution curves with an increase in temperature, we can draw these conclusions. The entire curve shifts towards the right. The most probable speed increases. The fraction of molecules with the most probable speed decreases. The curve becomes broader in the middle range, indicating that more molecules have speeds closer to the most probable speed. The fraction of molecules having higher speeds increases. The fraction of molecules having lower speeds decreases. It may be noted that the total area under each curve remains the same, as the sum of fractions of the molecules remains unaltered on changing the temperature. You have now reached the end of this module. In this module, you learned that Maxwell-Boltzmann distribution curves are curves drawn between molecular speeds and fractions of molecules. The speed of most molecules at a particular temperature is called most probable speed. At that temperature, lighter gases move faster than heavier gases. The most probable speed increases with an increase in temperature. The fraction of molecules having a lower speed decreases, and the fraction of molecules having a higher speed increases.